Hey guys, so this is our first lesson online. In the Google Drive, I dropped this PDF. It's not quite the same book we're using in class, but it'll work for us. Now, whenever I'm talking about page numbers, I'm not talking about the page numbers in the book itself, but the page numbers on the PDF. So this is page 280, but the book's page number would be 246. So we're going to go by these numbers, so it's actually easier for you to scroll to in the PDF. Okay. So let me get to page 285. We're going to start this example in a minute. So recap on what the normal distribution is. Remember, the normal distribution has a bell shape. It's a bell-shaped curve. If you read a problem and it says it's normally distributed or it has a bell-shaped curve, that's when you're going to be using a normal distribution. If it's not a normal distribution, the problem will say something like it's a binomial distribution. It'll tell you. So just read the problem and it'll tell you what kind of distribution you're dealing with. For now, we're just dealing with only normal distributions. So the standard normal distribution has a mean of 0 and a standard deviation of 1. So if you forgot, that's mu, population mean, lowercase sigma, population standard deviation. And in this chapter, if we're talking about area under the curve, that is the same thing as probability. So if it gives you the area, then you can use it just like the probability. If you probability and area are the same. So they're interchangeable. Whichever one they say, it'll ask you to find the probability, it asks you to find the area. You do it the same way. So we also have non-standard distributions, normal distributions. If you look at your formula sheet, we're in chapter 6 right here. So this is the formula you're going to use to convert it. I'll also drop the formula sheet in case you don't have yours for any reason. But this is the formula to convert your z-score to a normalized z-score. So 3 ways we're going to talk about how to find the probability. Chart, Casio, TI-83. So whenever you go to pick up your supplies on Wednesday, the school is going to have some of the calculators waiting for you. Make sure you get them so you're able to do the work. I'll also post some links to online calculators until then. So the chart, if we look at it in your formula sheet, down here, we're looking at negative z-score chart and the positive z-score chart. So these two are for your standard normal distribution. So if we don't have a standard normal distribution, you're going to have to convert it to a standardized normal distribution. Let's look at an example. So here's that example on page 285 I was telling you about. So if you want to look in the book, it's right here. They have their solution. Precision Scientific Instrument Company manufactures thermometers that are supposed to give readings of 0 degrees Celsius at the freezing point of water. Tests on a large sample of these instruments reveal that the freezing point of water, some thermometers read below 0, others read above 0. Assume that the mean is 0 degrees Celsius and the standard deviation is 1 degree Celsius. Also assume that the readings are normally distributed. If one thermometer is randomly selected, find the probability that the freezing point of water is less than 1.58, that the thermometer reads that. So first off, you've got to get the key info. Less than 1.58. That's telling us it's area to the left of the curve. Mean, 0 degrees Celsius. Standard deviation, 1 degree Celsius. So it's a standard normal distribution. All right, now, before you even try and do any work, sketch this thing. Remember, for a standard normal distribution, the mean is right here, it's 0. In any normal distribution, your mean is always right here at the top. The maximum is your mean. Now, 1.58, that's greater than 0, so somewhere over here to the right, I'm going to put that z-score, 1.58. So it says less than, so that's to the left of that thing. Highlight that. And that's our curve. The first way I'm going to show you how to do it is with the chart. So if we go to our negative z-scores or positive z-scores, let's see. Well, it's a positive 1.58, so we're going to go to the positive z-scores. We're going to look right here, 1.5. It's 1.58. The first two digits are on the left. Look at the top. Right here is 0.08. So this column right here is for 1.58 right here. So our answer is 0.9429. And again, this chart will always give you area to the left. It's cumulative area to the left. So that's how you do it with the chart. Yes, I know my disk is almost full. Hopefully we have enough space to get through this video. All right, so let's use the Casio. So for your basic screen here, we're going to go to Mode. Down, number 3 is the distribution. PDF versus CDF. So if we look at a normal distribution curve, what that PDF gives you is not the area, but the actual height of the curve at that point. So that's really not what we're ever going to want. We don't want to use a PDF. We want the cumulative area. We want everything behind that. I can't think of an instance where we actually use a PDF, so go with number 2, the CDF. That's the cumulative distribution. So if we need less than or greater than or even between, we're always going to use the CDF. So normal CDF, number 2. Lower bound, well, if I look at my graph here, my chart, it's going all the way to the left to negative infinity. So in the calculator, we're going to do negative 1. This button right here is times 10 to the 99. That's basically negative 1 followed by 99 zeros. So that's pretty much negative infinity. Upper bound, we're going all the way up to 1.58, so that's what we're going to do, 1.58. Standard deviation is 1. Mean is 0. It'll assume standard normal unless you tell it otherwise. So you can just go ahead, oh look. Again, we're going to go to 4 decimal places on these things. 0.9429, and it stays a 9. Same thing we got here. All right, so that's what we got with the Casio. Let's try the TI. So what you're going to do is you're going to go to second, VARs, and you're going to hit number 2, normal CDF. For me, it brings up this menu. For you, it's going to just pop this on the screen. So I kind of did it already earlier. But we're going to go to negative infinity. So we have a slightly different button here. We have a slightly different button here. We're going to go second comma, E99. So negative infinity to 1.58. I think my daughter wants to say hi. Alana, say hi to everybody. It's almost nap time. Hi. She just got out of the crib. But she needs to go back to sleep. I'm recording. Yep. Good night, Alana. I love you. Okay, apparently I don't love her. Anyway. Sorry. Negative infinity to 1.58. Our mean is 0. Our standard deviation is 1. Lower bound, upper bound, mean, standard deviation. Enter, boom, same thing, 0.9429. Slightly different from the Casio even if we go further out, but we don't really care. We're just going to 4 decimal places. So any way we do it, we get 0.9429. Let's look at this example. Again, the first thing we do is find our info. So using a thermometer from the preceding example, find the probability of selecting one thermometer that reads above negative 1.23. So from the previous problem, we know that our mean and standard deviation is 0 and 1, respectively. So plot my mean right here at 0. Above negative, it's negative, so that's going to go to the left. Put Z right there. And that's my Z, negative 1.23. I'm just going to put a Z down here so it doesn't clutter up everything. This time, though, we want area not to the left, but above, to the right. Oops, that's a little too big. So this is what we're wanting here. That area. So what I'm going to do for the chart, I'm going to again do it all three ways for these examples, is I'm going to look up in the negative Z-scores. So I'm going to go negative 1.23. Negative 1.2 is right here. Go to the top. This is the 3 column. I'll follow it down until right here. So that gives me 0.1093. But again, what does the chart give us? It gives us the cumulative area to the left, and we need to the right. So what that actually tells us is this right here is 0.1093. Rule of complements again. 1 minus this number will give us the area to the right. Because again, probability and area under the curve are the same thing. Probability has to add up to 1. So if I know to the left is 0.1093, to the right has to be 1 minus that number. So I'm going to do 1 minus 0.1093. And I'm just going to use a calculator because I'm lazy. Is this right here. So our answer is 0.8907. Okay, so that's the probability that one of these thermometers is going to read a number above negative 1.23 if it's stuck in some almost freezing water. So let's look at the Casio. I'm already in the normal CDF. So you can go look back how to get there if you forgot. Our lower bound this time is our Z-score, negative 1.23. Negative 1.23. Our upper bound is infinity, positive infinity, 1e99, or 1 times 10 to the 99. Mean and standard deviation haven't changed, 0.8906. It's different. Oh, wait, no, it's not. Don't forget to round. It's 89065. That 5 rounds to 6 up to a 7. So again, we get 0.8907 using the Casio. TI better give us the same thing. Second bars, normal distribution. So I'm just going to put random things in here so I can get it to just that blank function. Okay. Normal CDF, this pops on your screen. Lower bound is negative 1.23. Negative 1.23. Upper bound, I know, I might have to break this video up in a couple of videos. And we're going to do 1 times 10 to the 99. And for this mean and standard deviation, you could leave it blank since it's standard, or you can put it in there. 0 the mean, 1 the standard deviation, 0.89065, which again rounds to 0.8907. So any way we do it, we get the same thing. Give me a second. Let me see how we're doing on space. 1 gig so far. Yeah, I'm going to break it up. I'll be back just a minute with this example.